We are in the process here. This has been quite a learning curve for me as everything got just a little bit different. I was a little frustrated with those people from the regents who said that we teachers from the upstate region don't know how to do videos and teach from a distance. So I guess I have to prove them wrong, right? Okay. So anyway, today we're going to take a look at the first lesson in finishing up the GCC requirements. All right, and this first lesson is going to be on finding solutions to nonlinear systems. All right, so what we're talking about with a nonlinear system is that one equation might be a line, all right, but the other equation isn't going to be a line. So remember all of the different kinds of equations that we had. All right, we have circles, all right, we have parabolas, all right, we have ellipses, all right, and we also have hyperbolas. Right? So we can have a line that intersects with any of those equations. So just to kind of give you a little reminder, an equation of a circle, x is going to be squared, y is going to be squared. They're going to have the same coefficient and the same sign, and it equals the radius squared. All right, so in a question like this, all right, the radius is going to be 4. All right, for a parabola, either x is squared or y is squared. The ones that we're used to seeing and generally are at this level would be the y equals x squared. I don't know why, but I always use 7 and 3 when I'm not thinking, when I make up an equation. Anyway, in this case, x is squared, y is not. All right, so this is going to be a parabola that opens up. Parabola that opens down would have a negative a term. A parabola that opens to the right would be x equals y squared. And a parabola that opens to the left would be x equals negative y squared. All right, an ellipse, x is squared, y is squared, but they have different coefficients. So 5x squared plus 7y squared equals 14 would be an example. All right, they have the same sign, and they have different coefficients for the x squared and the y squared. All right, and then a hyperbola, they're not going to have the same sign on the same side of the equation. All right, so one's going to be positive, one's going to be negative. All right, so what we're talking about is an intersection with a line with one of these kinds of equations. All right, so our first example, and this may take up some space, all right, is going to be x squared plus y squared equals 5. All right, and that's going to be a circle, and it's going to intersect with x minus y, well, hopefully it does, equals negative 3. All right, so this first example I'm going to do with a calculator, and we're going to find the intersections. All right, in order to do that, we have to solve both equations for y. So x squared plus y squared equals 5. I'm going to subtract x squared to get y by itself. So I have y squared equals 5 minus x. All right, and then we take the square root of both sides to get y by itself. And we get y equals the square root of 5 minus x, x squared, and y equals the negation of 5 minus x squared under the radical. All right, and for the line, we have x minus y equals negative 3. So we're going to add y to both sides. X equals y minus 3, add 3, and y equals x plus 3. All right, so what we need to do is we need to put all three of those equations in our y equals screen. Okay, so y equals, we do the x plus 3. Is that what I got? Yep. All right, and then y equals the square root of 5 minus x squared, and the negation of the square root of 5 minus x squared. All right, so then if we push zoom 6, that takes us back to our standard window, just in case we were doing something different before. All right, try to find a place where this is going to show up well, and there isn't one. But if you look closely at your calculator screen, all right, that line does actually go inside that circle. So if I do zoom square, what that does is it makes the negative 10 to 10 for the x and the negative 10 to 10 for the y the same size. All right, so you can see that one maybe a little bit better, but not much. So I've got a little bit of an issue with this. I really want to see what's going on. So I'm going to go back in, I'm going to change my window, and I'm going to take my window from negative 5 to 5 for x and y. All right, and then push graph. Okay, so now, again, this thing didn't come through very good. How about if I do that? Yeah, that's a little bit better. All right, so we can actually see that that line does go inside the circle, so there's going to be 2 points of intersection. All right, now this one works out so that you could actually do it in the table, but that's the easy question. They're not always going to do that. So I want to show you the way that works all the time to find those points of intersection. All right, so second trace intersect. All right, and notice it starts out on the line on the y-axis, right? That's just because I put that one in first. All right, so the right arrow and the left arrow move along the graph that you're on. The up and down arrows move between the different graphs, different functions that we put in. So if I have an intersection with the top circle and the bottom circle, I've got to go up and down to move to the proper circle. All right, so we're going to go back to where we started. It's asking for the first curve. So I hit enter to choose the line. Now it's asking for the second curve. It moved to the top of the circle. So I push enter. And now it's saying guess. All right, remember there's 2 points of intersection. So I'm going to go closer to the top one. All right, and when I guess the next time, I'm going to do the same process, but I'm going to go closer to the bottom intersection. All right, so we got our answer from the calculator. So that means we need to sketch the graph. All right, and that first point of intersection is negative 1, 2. All right, so that's the first solution. All right, so we go back to second trace intersect. All right, I'm going to move my cursor just to see where it is. All right, again, second curve is the top of the circle. This time when I guess, I'm going to move closer to the other point of intersection. All right, and the intersection there is negative 2, 1. All right, so both coordinates, the x and the y, all right, for each coordinate is my solution. Okay, so that's the graphical approach. Sometimes they let you do that. Sometimes they require you to do that. But sometimes they ask you to do the solution, find the solutions algebraically. All right, so I'm just going to check here something, guys. This is only the second video that I've made, and I want to just make sure that I am recording because it's kind of a pain to go back through this. I'd hate to do the whole thing and then have to. All right, where did my screencastify go? Okay, now I think it's working. It says that it's sharing my screen. All right, so example 2, what I want to show you is what if they say to find the solutions algebraically. So my first equation is x squared minus y equals 6. My second equation is 5x minus y equals 0. Okay, so the first equation is a parabola. X is squared, y is not. Y equals x squared. All right, the second equation is a line. So if you think about a line and you think about a parabola, right, they can intersect in two places. It could just clip part of the parabola and intersect in one place, or it could miss completely and there are no solutions. All right, so we don't know for sure as we work through this, but what we have to do for the algebraic method is to solve for one of the variables in the line and then substitute what you get back in the first equation. All right, so I'm going to take this 5x minus y equals 0 and solve for y, because the y is by itself, and y is equal to 5x. All right, so the first y and the second y are equal. All right, the second y is equal to 5x. So that means I'm going to take the 5x and put it in place of the first y because all three of those are the same. All right, so x squared minus 5x equals 6. All right, so when you're solving a system of equations, guys, your goal is to get rid of a variable. Notice in this equation I have no more y's. All right, so I can solve for x. So I subtract 6 from both sides. I get x squared minus 5x minus 6 equals 0. All right, so we have a quadratic. We've got 4 ways to solve that. Factor if it will is the quickest. We could also do the quadratic formula. We could graph it, but this is algebraically, so we can't graph it. Or we could do completing the square. All right, this factors, and factoring is the quickest way to get this. All right, so I want factors of 6. The signs are different, so they subtract to be 5. The larger factor is minus. So x minus 6, x plus 1, which makes my solutions 6 and negative 1. All right, so now I found the x's. Remember, I need the x and the y for the 2 points. This parabola, all right, and this line intersect in 2 places. So I've got to take these x's, plug them back in. All right, so I'm going to use y equals 5x. So y equals 5 times 6 is 30. So I put 6 in. 6 was my x. I got 30 out. All right, that was my y. Y equals 5x. This time I'm going to put the negative 1 in. And y equals negative 5, which makes my solutions negative 1 and negative 5, my solution. Okay, so there we are. We've got our 2 solutions. The line, 5x minus y, intersects with the parabola, x squared minus y equals 6 in 2 places. And these are the 2 places. All right, now I chose this one for the algebraic because you really have to do some messing with your window to find that 630. But, you know, they're not always so nice to you on the regions. Okay, so solve the following system. We're going to do this page with graphing, and we're going to do the other page with algebra. Okay, so I've got these two equations. I'm going to put them in the calculator, and I'm going to sketch the graph. All right, so going back to my y equals screen, zooming in. All right, I'm going to clear the equations I have in there. All right, so y equals negative x squared plus 2x plus 1 and 2x plus 1. All right, so zoom 6 back to our standard window. All right, so we have a parabola that opens down. All right, and we have a line and we just have one point of intersection. All right, so second trace intersect. First curve, all right, it's on the parabola, so I choose enter. Second curve, it automatically moved to the line, so I hit enter and guess. All right, so the solution is 0, 1. Even though that doesn't look like 0, 1, right? They both do round, right, to 0, 1. So this is scientific notation. Negative 2.989 e to the negative 7 is negative 2.989 times 10 to the negative 7th. Moves the decimal place 7 places to the left, gives you 6 zeros, all right, which to the nearest hundredth is going to round to 0. And 0.9999994, right, rounding to 2 decimal places, the 9 makes the other 9 go up to a 10, right, and that rounds to 1. Okay, so that is the process. Your assignment is just to finish the page, all right? Oops. And on the back, we're solving algebraically. All right, now these are all pretty similar, and these are pretty simple. I should have thrown some extra ones in there for you, but we'll start out with these. Okay, so remember the first y and the second y are equal to each other. The second y is equal to x plus 1, so we're going to put the x plus 1 in place of the first y. All right, so we have a quadratic, so we get everything to one side. Some people just say set it equal to 0, which is basically the same thing. All right, so remember, a line can intersect with a parabola in no places, one place, or two places. All right, so here we have a quadratic. We're going to factor out an x, which makes our factors x and x minus 3. Set those factors equal to 0, gives us solutions of 0 and 3. All right, so remember, there's two solutions. I need the x and the y. Y equals x plus 1. If we make x 0, then we end up with a 1. So the input was 0. That's the x. The output was 1. That's the y. All right, y equals x plus 1. If we substitute the 3 in this time, we get a 4. So when our output was 3, when our input was 3, our output was 4. All right, so those are the coordinates of our intersections. All right, so guys, again, your assignment for this is just to finish these two pages and then get them back to me. I guess you probably have to send them to my email unless we come up with a different way. And I think that's going to be the only way. with this one. All right. So anyway, there's lesson 1. We have 5 more lessons to go, and we will get those to you. The plan is 3 a week. All right. Have a good day. Let me know if you have any questions.